Long before humans appeared, Earth belonged to giants. Forests were filled with insects larger than birds. And across ancient landscapes, animals the size of buildings once walked under the sun. Today, their fossils feel almost impossible. A dinosaur bone can be taller than a person. A single megalodon tooth can be larger than a human hand. So why did Earth once produce creatures so enormous? The answer is not one simple thing. Different giants appeared at different times. Because Earth itself kept changing. More than 300 million years ago, during the Carboniferous period, the planet was covered in vast swamp forests. The atmosphere may have contained much more oxygen than it does today, and for insects, that mattered a lot. Insects do not breathe with lungs like humans. Oxygen moves through tiny tubes inside their bodies. When the air contains more oxygen, that system can support larger bodies more easily. This may help explain creatures like Meganeura, a dragonfly-like insect with a wingspan of around 70 centimeters. Imagine a giant insect flying through a swampy forest, long before birds existed. But oxygen does not explain every giant. To understand the largest land animals, we need to move to the age of dinosaurs. The greatest giants were the sauropods, long-necked dinosaurs like Diplodocus, Brachiosaurus, and Argentinosaurus. Some were longer than a basketball court. Some may have weighed as much as several elephants combined. Their bodies were built for giant size. Many had efficient breathing systems, possibly similar to modern birds. Their bones also contained air spaces, making parts of the skeleton lighter without making it weak. Their long necks helped them reach huge areas of plants without moving their massive bodies too much. For an animal that large, saving energy was extremely important. Sauropods also laid eggs. A giant mammal must carry a developing baby inside its body. But a giant dinosaur could lay many eggs, and the young could grow slowly into enormous adults. Still, giants need a world that can support them. A huge body needs huge amounts of food. During much of the dinosaur era, Earth had warm climates. Large plant communities, and ecosystems that lasted for millions of years. When an environment stays stable for a long time, evolution has room to experiment. Some animals become faster, some become better protected, and some become enormous. But giants were not only found on land, the oceans also produced monsters. Megalodon was far larger than any shark alive today. It hunted in seas filled with large marine mammals, including whales and other prey that could support a predator of that size. In water, being huge is easier than on land. The ocean supports the body. A giant animal does not fight gravity in the same way. That is why the largest animal ever known is not a dinosaur. It is the blue whale, and it is still alive today. This means the age of giants never fully ended. But being giant has a cost. A huge animal needs a lot of food. It often grows slowly, it may reproduce slowly, and it usually needs a large area to survive. When the environment changes quickly, giants can be in danger. Small animals can hide. They can survive on less food. They can reproduce faster. But a giant is tied to the world that supports it. If that world collapses, the giant may fall with it. Around 66 million years ago, a massive asteroid struck Earth. Dust and debris filled the atmosphere. Sunlight was blocked. Plants struggled. Food chains collapsed. Many large dinosaurs could not survive, but smaller animals had better chances. Some birds survived. Small mammals survived. Reptiles, insects, and many marine animals survived. After the asteroid, mammals began to rise. Over time, they also produced giants, giant ground sloths, mammoths, giant rhinos, and many other enormous animals. But many of these giants disappeared much more recently. Climate change played a role, and humans may have contributed too. As people spread across the world, large animals faced hunting pressure, habitat change, and competition. So why does Earth no longer have as many giants? The atmosphere changed, the climate changed, ecosystems changed, mass extinctions removed many giant lineages, and humans changed the world faster than many large animals could handle. But Earth has not lost the ability to create giants. The blue whale proves that. It is larger than any dinosaur we know. It can grow longer than a commercial airplane, and its heart can weigh as much as a small car. The story of giant creatures is really the story of Earth itself. When the air changed, life changed. When oceans warmed or cooled, life changed. When disasters struck, some giants disappeared, and new forms of life took their place. The giants of the past were not fantasy monsters. They were the result of real biology, real climates, real ecosystems, and millions of years of evolution. There was once an Earth of giant insects, an Earth of towering dinosaurs, an Earth of ocean predators larger than buses, and even now, beneath the waves, the largest animal ever known still moves through the blue darkness. The age of giants may feel ancient, but in some ways, it never completely ended. But the giants that came after the dinosaurs were different. They did not dominate the world in the same way sauropods once did. They lived in colder grasslands, open plains, forests, and isolated continents where evolution followed unusual paths. In North America and Eurasia, mammoths walked across frozen landscapes, using their thick fur and curved tusks to survive the Ice Age. In South America, giant ground sloths moved slowly through ancient forests and grasslands. Some were tall enough to reach tree branches while standing on their hind legs. In ancient Australia, massive wombat relatives wandered across the land. And in parts of Asia, giant rhinos became some of the largest land mammals that ever lived. These animals show that giant size did not disappear with the dinosaurs. It returned again, but under different rules. Mammals could become huge, but they were limited by the way their bodies worked. They carried their young inside the body, they produced fewer offspring than many reptiles, and they often needed more time to grow. That made them powerful, but also vulnerable. When the climate shifted at the end of the Ice Age, many of these giants faced a world changing around them. Forests expanded, grasslands moved, food sources changed, and at the same time, humans were spreading into new lands. For many giant mammals, this may have been too much pressure at once. They had survived cold, drought, predators, and thousands of years of change.